All right, let's get into it. Implementing basic redistribution. What I have planned here is a scenario setup. Well, let me just show it to you. There it is. Here's our scenario where this is just going to be a basic redistribution scenario with some deeper requirements than just doing the simple redistribute command. We've got router 1 over here with a few loopback interfaces. Router 2 is our redistribution point of the network. And then router 3 is over here with a bunch of loopbacks of his own. So let's bring the lab up and take a look at our requirements. So first and foremost, let me shrink this down a little bit. There we go. It comes up and says we need to configure EIGRP and OSPF for the network shown. Should be easy. Advertise all networks on our routers. Good. Do not implement any summarization features. Good. Use area 0 for OSPF. And configure all loopback interfaces on router 3 as a point-to-point OSPF network. Okay, seems like a pretty straightforward start. I'm going to walk you through this entire thing from start to finish because I want you to see the configuration on the redistribution router. So I've got router 1 sitting right here. I'll log into him. Now router 1 is again over here in the EIGRP Autonomous System 100 domain. So let's go in and set him up quickly. Should be easy. Router EIGRP 100. Network 10, let's just be silly on that. No auto. Simply because he's got the loopbacks with all 10 interfaces, the serial interface, and there's no other routers over here that we're trying to prevent neighbor relationships from, so that should be really easy. Router 2, we have to be a little more specific. Let's hop over there. Go into global config mode. I'm going to hit router 2. Now EIGRP I just want turned on over here, so I'm not going to use 10.0.0.0 as the network because I don't want EIGRP bleeding over here into this network. So I'll go into router EIGRP 100, no auto, and we'll do network. Let's see, it was 10.1.12.0 is the WAN link between the two. 10.1.12.0. Good. So that should, there we go, form the neighbor relationship between the two. Now, since this is our redistribution router, he's going to be running the OSPF protocol as well. So let's go in and do router OSPF 1. I'll do network 10.1.23.0 area 0. And that was specified in the lab documents. And I'm not even going to bother with the router ID because it's a pretty straightforward setup. Last one to go is going to be router 3. So let's go over to router 3. Enable. So did you notice that on router 2 there was no special configuration that we had to do to make it a redistribution router? It's just right now it's a router running 2 routing protocols. So once I get this guy set up, see, and this proves that I cannot talk and type at the same time. There we go, wildcard mask. So I'm advertising all 10 networks. Good. So let's just verify. I'm going to shoot over to router 2. I saw the neighbors come up. Let's do a show IP route. And you can see we've got all of these routes coming through, a bunch from the EIGRP side of the world. Those are our loopbacks over there. And a bunch from the OSPF side. Now notice right now you can see the reason why the lab said to configure all loopback interfaces on router 3 as a point-to-point OSPF network. That's all these guys. The reason it did that is because by default, as you might remember from some of the previous videos, OSPF will advertise those loopback interfaces as host addresses, a /32 mask, and we want them to look like a real address or a real network. So I'm going to do a show IP interface brief on router 3. Let's do interface loopback 7, IP OSPF network point-to-point, and then it's just simple repetition there. 9 OSPF network point-to-point. 10, 11, 12, 12, and 13. There we go. Good. So all those are configured with the right OSPF network. So now when I do a show IP route, they should appear, well, it looks like some of them are still getting there, but you can see the majority of them Now all of them are appearing as real networks. These are /30s, and you can see right there on the network diagram, those show up as /30s. The rest of those appear as /24s now instead of that /32 host mask. So we're good. I would say step 1 is now good to go. We've got EIGRP and OSPF configured. Router 2 is just running both routing protocols. It's not redistributing. Practice that word. So enable full redistribution between OSPF and EIGRP. Easy. Implementing any necessary seed metrics to ensure all routers are able to see all routes. OSPF external routes should not increment their metric as they propagate the network. Okay. Before I do this, a few words of wisdom. It says, first off, full redistribution. That makes it very easy. So no filtering as of yet. Then it says implementing any necessary seed metrics. So what's a seed metric? A seed metric is what metric does it start with. Remember, when we're sending these EIGRP routes over to OSPF, EIGRP is not going to translate its cost or its metric because they are totally different metrics. OSPF uses cost, EIGRP is a composite metric. So I need to specify what metric these routes have as they come over. Now, EIGRP, when you distribute those, has an infinite metric by default if you don't specify anything. So that means that those routes will not show up over here because it's going to say, well, they're infinitely distance away, so it must be unreachable. OSPF, on the other hand, has a default metric of 20. And yes, I'm sure in a RFC cabinet somewhere there's a dartboard where somebody threw a dart, hit the number 20, and said, let's make it that. So a couple things to know. If you're redistributing RIP or EIGRP, their metric is both infinite by default. OSPF and BGP will have a default one by default. OSPF will be 20. BGP will be whatever it was when you redistribute it from the internal network. Now, BGP is a special one, special case. We'll talk about BGP when we get there. Just say, I'll just put keeps. It keeps whatever metric the other routing protocol had. So let's test this out. Bring the console back up. Now, the action's going to happen on router 2 because router 2 is where we're going to do that redistribution. So I'm going to go on router 2, go into global config mode. Let's do router. Let's go into OSPF first. Router OSPF 1, and I'm going to type in the command redistribute EIGRP autonomous system 100. That was the EIGRP network over here. So I'm saying, now notice, a couple things. I've gone into the protocol that I want to send the routes into. I want to send those EIGRP routes into OSPF. So I went into OSPF and I'm saying redistribute EIGRP. And let's hit the question mark. Now you notice a few options under here. I can specify the metric. I can specify the metric type. Now the metric type is going to be those E1 or E2 routes. Remember those? Where you can specify that, and I'll do that in a moment. Notice I also can do a route map. We'll talk about that later. This is the key I want to talk about for now. Subnets. By default, when I send redistribute routes into OSPF, it's going to try and summarize them. Now, anything automatic that happens like that, I hate. I want to be able to summarize by myself. And you might remember from the lab, it says do not implement any summarization features for EIGRP or OSPF. So summarization is not an option here. So I'm going to say send the individual subnets. Don't try and summarize it back to a Class A network. Tag we'll also talk about later. So for now, let's just hit enter and see what happens. I'm doing redistribution. I'm going to go over to router 3 and do a show IP route. Let's bring this a little larger so we can see more of what's happening. Notice router 3, which is right here, now has all of these routes from the EIGRP domain. Notice, by default, and this would be another thing worth remembering, they come over as E2. You remember? What did I say? Something like that. I don't know what I said. You might remember. How's that? E1 and E2 were the two options we had for OSPF. E1 routes increment their metric. E2 routes do not increment their metric as it goes through the network. Now let's look at that again. Look at the metric. It is set to 20. You remember that was going to be OSPF's default metric, and that's fine. We can leave it set to 20 if 20 works for us. If we want to, we could go into router 2. Let me hit the up arrow again and do metric. Let's do metric of 100, and that would be fine too. And I would come back over here to router 3 and notice that all of the metrics have changed over to 100. You can specify the metric, but looking at the lab, it didn't say whether to specify the metric or not. All it did say is OSPF should not increment their metric as they propagate the network. Now, the good news is that when we did this, the default is a type 2 route. So this right here is the default. Default of 20 metric, default type E2. So by default, it won't increment that. But I'll tell you what, if the lab said that, I would totally not feel comfortable going with the default because I am a hard code everything, everywhere kind of guy. I would go into router 2 and I would make sure of it. I would say, metric type 2. Just so I know that it's coming through as a type 2. Let me do a show run and do the section OSPF. And you should see that it's now combined that all into one command. Redistribute EIGRP 100, metric 100. We type that subnets. Now, question for you. Where's that command? Where's metric type 2? It didn't show up there. And that's okay, because it is a default. So the Cisco router took that and said, okay, yeah, that's default, no worries, gobble up. And it's going to gobble up that command, not actually show it to you. Now, if you typed in metric type 1, whoops, you would definitely believe it will show it to you under there because that's no longer the default. It's just when you flip it over to 2, it's going to hide it because that's now a default command. So, all that being said, we now have redistribution into OSPF. So let's drop back, and now we want to configure redistribution the other way. I'm going to go into EIGRP. So once again, I'm going to go into the routing protocol. I want to redistribute into EIGRP 100. Type in redistribute OSPF process ID 1. Now you notice I don't have as many options under here, but I do have a few. Match, if I want to match certain types of that's not what I meant. If I want to match certain types of OSPF routes, like internal or external or not so stubby area external routes, I can specify those. But if you leave that off, it'll just send all the OSPF routes. You can specify the metric. I can do route maps or VRF. We are not even going to touch. That's virtual. It's like VMware for routers, virtual router forwarding instances. So let me shoot over here. Wait a sec, did I hit enter? No, I haven't hit enter. So I'm going to hit enter because I want to prove something here. When I do redistribute OSPF 1 on router 2, it is now sending the OSPF routes into EIGRP, but when I do a show IP route on router 1, they don't show up. And the reason why is because they are being redistributed with an infinite metric. You remember that was the default right here. Infinite metric is not going to be a valid route, so we have to go into router 2 and specify the metric. It's not like it has the default of 20 there. Now, EIGRP has a painful metric to type in. You can see bandwidth metric and kilobits per second, because remember, EIGRP uses bandwidth, delay, reliability, loading, MTU as its metric. So what I usually do here is I just use something like 100. I'm going to say 100, 100. You see, it's the delay, reliability, loading, MTU. I just do that because it's very quick and easy to type. Unless the lab specified what metric to give it, frankly, I don't care what the metric is. I'll just hit enter and watch magic happen. Now I'm going to come over here to router 1, and you can see the metric is definitely ugly because it goes into that big formula, but I don't care. The external routes are showing up. You can see they are now showing up as EIGRP external routes. Sweet. So all those are coming across. We now have full redistribution going between those. So I would say at this point, step 1 and step 2 of these objectives are done. Now let's drop down to step 3. Implement distribute list filtering in such a way that the OSPF domain only sees odd number loopback networks coming from router 1. Okay, so I'm looking at the loopbacks. You see 10.1.0, 10.1.1, 2, 3. So if it's saying odd numbered loopbacks, I'd be looking for 10.1.1, odd number, 10.1.3, and 10.1.5. Any even number subnet, including physical networks, should be hidden from OSPF. Notice that this is an even numbered subnet, and so is 0.0, 2.0, 4.0, and so on and so forth. You see that? So here's how distribute lists work. Let me Oh, that was a little more aggressive than I would have hoped. Then I won't clear it off. So here's how distribute lists work. Distribute list allow you to say, I only want to send certain routes down to this router. Now, a distribute list is always built from an access list, meaning the distribute list is a command under the router process that applies an access list for incoming or outgoing route updates. So it's a lot easier to show you than to fully explain it. Here's what I'm going to do. I'm going to go on to router 2, exit back out. I'm going to type in access list, and I'll just use a standard access list. Doesn't have to be anything fancy. Let's do standard access list 1 for this. And I'm going to do a permit, and what I'm going to do is permit all of the odd numbers subnets. So I'm going to look here and do 10.1.1, 10.1.3, 10.1.5. Now, I know some of you superstars out there are thinking, you know, you can get really fancy with the wildcard mask where it would permit all odd-numbered subnets, you know, using like a wildcard mask of 1.255. If you want to do that, bonus points for you. You can go there. I'm not going to go there. I'm going to keep it basic. I'm going to permit these odd-numbered subnets explicitly with this access list. Now, as of right now, this is just a lingering access list. It's not applied to anything. So I'm going to go into router OSPF 1 and do distribute list, and you can see access list 100. So I'll say access list, or access list 1, that's the one I just created above. And then it says incoming or outgoing updates. Now, again, remember, we're looking from router 2's perspective. I'm going to filter them as they go out. Leave, you know, be the router when you're thinking of incoming or outgoing. So as they go out to router 3, I want to filter it using access list 1. So before I hit the enter key like on this, I'm going to go to router 3, do a show IP route again. You can see I'm getting all the even and odd numbered subnets. I'm going to go to router 2, distribute list 1 out, and if you want, you can specify a specific interface or a certain type of route. I'm just going to say out anywhere and hit enter. So at this point, it's now filtering out. I'm going to go back to router 3, do show IP route, and look at that. Moment of silence. There it is. We've now filtered it down to just 3, just 1, and just 5, which looking back at our diagram is exactly what we wanted. The odd numbered subnets from the EIGRP domain. Groovy. So at that point, we've now accomplished at least part of this, right? Distribute list, so OSPF, no, that's all of it. So that is step 3. We've now filtered that. Drop down here, it says implement route map filtering in such a way that the EIGRP domain does not see routes with a more specific subnet mask than /24. Okay, that one's a little bit weird because using an access list, it's very difficult to do. Now, you could go in and you could filter it and say, I only want to permit 10.1.7, .8, .9, .10, and .23 to come over. And I would say, arguably, that would be a viable solution. However, I want to show you how prefix lists work to demonstrate this. Prefix lists are a powerful thing that Cisco has created to allow you to get very, very specific with what subnet masks and what routes you want to allow through. They created it specifically for route filtering, and I'll say most of the time it's applied to BGP. However, we can also apply it to other things like route redistribution. Here's the way it works. With a prefix list, you configure it by saying, I want to create a prefix list. I'll just put PL, and you give it a name. So I'll say, you know, whatever name you want. I'll name it Jeremy. And then you get to say, I would like to permit, it's kind of like permit and deny, same things, the general network, and you just put whatever general network and mask you want right here. Then you get to say the specificity, if that's a word, of the subnet mask you want to allow. Let me give you an example, and then I'll come back and explain it more fully. I'm going to go on router 2. Where the filtering is going to happen, and I'm going to say do IP prefix lists, That's the command to do it. And you give it a name, and we'll say this will be named Jeremy. It is case sensitive, so if you name it with all caps, you got to remember that. So I'll put Jeremy, and then we say permit or deny. And I'll say permit. Now, what am I permitting? And notice it kind of gives an example here. What is your major network that you want to permit? Well, I'm looking at my diagram, and I want to say I want to permit all 10 networks, meaning any network that starts with the number 10. Now, if you were to write that in decimal format, you would say 10.0.0.0, and anything was 10. It's 255.0.0.0. That's decimal format. But we're now moving to a CIDR notation. So another way to write that, if you were to write that, would be 10.0.0.0/8, right? Everybody's familiar with CIDR notation. That's another way of writing that. That is considered the general network that I'm permitting. So I'm going to come back here and I'm going to say I want to permit 10.0.0.0/8. And I love this. Finally, we have a command that allows us to use this notation versus the decimal. Now you notice from there it gives me the option to hit enter, or I can say GE or LE. Think of this as greater than or equal to, or less than or equal to. So let me stop right there. Pause for a moment. Notice I said prefix list Jeremy permit 10.0.0.0/8. If I hit the enter key right now, you know what's going to be permitted? Exactly the 10.0.0 network. So for instance, if I was doing redistribution and the OSPF network actually had a network that was 10.0.0.0, let's say over here there was 10.0.0.1/8 or something like that. The whole 10 network was being sent. This prefix list, if I were to hit the enter key right now, would permit just that network, nothing more. So all of these more specific networks over here would end up being denied. So would this WAN link would be denied from being redistributed. That's not my goal here. Remember the goal, it said implement route map filtering, which you might be saying, wait a sec, that's not prefix list. It will be, just a moment. Route map filtering in such a way that the EIGRP domain does not see routes with a more specific subnet mask than /24. So what I'm going to do is I'm going to go back here to router 2 and add on the keyword less than or equal to 24. Enter. Let me explain. What that does when I'm doing that is it says I'm going to, I created a prefix list named Jeremy. I'll just put Jer, where I'm permitting the entire 10.0.0.0 network /8, and then I added on less than or equal to, essentially, think of it this way, /24. So what it's going to do is any network that comes in, it's going to say, first off, are you a 10 network? Meaning, let's say this guy comes in, 10.1.7.0. He's going to come in and be processed by this filter. He's going to say, hello, my name is 10.1.7.0 /24. Prefix list is going to say, are you part of the 10 network? Route is going to say, absolutely, yes, I am. I start with the number 10, just like you're looking for right there. That's me. The next question it's going to say is, do you have a subnet mask that is less than or equal to a /24? To which this route will answer, why, yes, I do. I happen to be exactly equal to 24. And the prefix list will say, welcome, my friend. You are permitted to go through and pass to the other side. Now, let's say one of these other routes come through. This guy comes in, 10.1.11.8/30. Again, the prefix list would ask, are you part of the 10 network? To which this route would answer, absolutely, yes I am. I belong to this class of network. Then it's going to say, do you have a subnet mask less than or equal to /24? To which this route will say, I'm sorry, I don't. I have a /30, which is greater than a /24 and on the specificity, and the prefix list is going to say, then I'm sorry, my friend, you are not allowed through. You are not less than or equal to a /24. Does that make sense? So what other subnet mask would qualify there? Well, let's say you had a route that was 10.5.0.0/16. Would that qualify? Let's say that was one of the loopbacks, 10.5.0.0/16. Would that qualify? Well, as it comes in, it would say, yes, I'm part of the 10 network. I matched this guy right here. And then it would say, are you less than or equal to a /24? To which it would say, absolutely, yes, I am. I am a less than or equal to. I'm a /16. I'm less than a /24. So that's how this little keyword works. Now, if I were to change that to GE24, that would say greater than or equal to a /24, at which point all of these networks would be allowed because they are either equal to, that's all the /24, or greater than. The /30 is greater than a /24. Do you see how that works? Now, this guy, the 10.5.0.0/16, would not be allowed because he is not greater than or equal to a /24. So pretty weird, but that's how prefix lists work. Toughest thing for me to get when I got into prefix lists was kind of separating this initial statement right here, the 10.0.0.0, from the subnet mask. Because I would initially look at all these. Let me change my pen color real quick. I would look at all of these subnets over here, and I'd be like, oh, well, none of them match because none of them are 10.0.0.0. Well, that's not how it works. Think of this first statement as like your wildcard bits. It's saying anything that starts with the number 10 because it's a /8 at the end of it. Anything that starts with 10 but then has a subnet mask less than or greater than or whatever we want to do, /24 is how it fits. So again, a little weird, but that's how it ends up working. Now, if you're feeling like a superstar, you can actually go further than just LE or GE. You could, my inner monologue is saying, Jeremy, don't say it, don't say it, don't say it, but I'm going to say it. You could do a prefix list. Let's do an IP prefix list, Bob. And I could do, permit 10.0.0.0/8. And then I could throw something out there like GE 16 LE 24. You can actually combine multiple ones in a statement, and that's going to match any subnet mask between 16 bits and 24 bits, including 16 and 24 bits in length. So you can kind of box it in and say just these sort of subnet masks. But again, if that's like over the top for you, if you're like, all right, that's it, then pretend I didn't say that. That didn't happen. Just think of the LE and GE, because that's, I would say, most of what you're going to end up doing. So let's come back to our scenario. We were seeing, it said, implement route map filtering in such a way that EIGRP does not see routes with a more specific subnet mask than /24. So all these guys are allowed, these /24s, these guys are not. So come back to our configuration. The prefix list is just half of it. We've got the prefix list, Jeremy, permit 10.0.0.0/8. LE, that's less than or equal to a /24, which is exactly what the scenario is looking for. Now, you notice that the scenario said implement route map filtering. You might say, well, we're doing prefix list filtering, not route map filtering. Well, route maps really just use other filters and apply it to the redistribution command. Let me show you. I'm going to do, let's say, route map, and you give it a name. So we'll call it filter OSPF to EIGRP. That is a long name, but we'll go with it. Filter OSPF to EIGRP. It is case sensitive. And then you have sequence numbers. Now, if you don't type any sequence number, it's going to automatically begin with sequence number 10. So I'll just hit enter right there, and it's going to, let me do a show route map. You can see it's already created sequence number 10 for filter OSPF to EIGRP, and it's a permit, meaning do this sort of statement. So I'm going to say route map, and once I get under the route map, have we talked about route maps here? I think I mentioned in the previous nugget that it was kind of like a scripting language. Let me clear off some of this so I have some room to write. It's scripting language for your router. It's just a group of if-then statements is really all it boils down to. I say, route map, we'll say OSPF, that's the name, sequence 10. And then I say if such and such criteria, then such and such criteria. And then you do another statement, route map, OSPF, 20. If such and such criteria, you do all your if statements and then you put your then statements that is in there. It's kind of like, I don't know if any of you go back this far, but you remember back when I had my Commodore Amiga, I tried to, this is where I first got into programming, and I learned a programming language called BASIC. And you would go into BASIC and you would say, okay, 10. Echo, hello world. That's the first program everyone writes. And then you'd say line 20, go to 10. and you hit execute, and the screen would fill with hello world because it's a looping program which it just keeps printing the words hello world. And I ran that. I was like, that's lame. I didn't even get into programming back then. But that's kind of, but they're not lame. Route maps are really cool. They allow you to do whatever you want in many situations. This is not the only time that we're going to see them. But instead of saying if then, Cisco says, you say match and set. So essentially match such and such routes and then set some kind of criteria. Now in our case, we're going to come back to this. And I'm going to say match. You can see that really the only two real commands from this list is match and set. So I'm going to say match question mark, and you can see I can match on all kinds of different things. I'm going to say the IP address, and I'm going to use my prefix list, and that was the one named Jeremy, I believe. Right there, yeah. Prefix list Jeremy. Okay, so I'm going to match that. And what am I going to set? Well, frankly, nothing. There's nothing that I need to set for that route map because I'm just saying permit just those routes to go through. Now later on we'll look at ways to set the metric, to set all kinds of different criteria as it passes through this route map, especially when we get into BGP. And I'll explain a lot more about route maps then. But all I'm doing right here, when I do my do show route map, is I'm just saying sequence number 10 of this route map is just going to match or permit the routes listed in the prefix list Jeremy. Now I need to go to router EIGRP 100, which is where I did, whoa, hang on, lost myself there, which is where I did my initial redistribution where I was saying send the OSPF routes to EIGRP. And what I'm going to do is I'm going to attach that. Let me do this so I don't have to retype the whole command. I'll do a show run section EIGRP. There it is. There's my command. I'm going to redistribute OSPF metric blah blah blah. You see all the metric that I have typed in there from before. And I'll hit the question mark, and you can see that I'm going to filter this redistribution through the route map, and then my route map name is right here. Filter OSPF to EIGRP. Now, hang on, before I do this, let me go over to router 1. Do a show IP route, and I just want to verify that you are seeing all of the routes, the /24 external routes and the /30 external routes that are being redistributed. What I'm going to do is I'm going to pass it through that filter, the route map filter, come back over to router 1, do a show IP route, check it out. All of the /30 routes, or any, let me broaden that, any of the subnets that have a subnet mask more specific than a /24 are missing. These are all derivatives of that /24. All the /30s have gone away and been filtered by that route map. Now I can go back and do a show route map. Whoop. Show route map, and you can see that this is what's happening. We've got the route map now applied. IP addresses that are being filtered through that prefix list Jeremy. I'll do a show IP prefix list. You can see there's my one statement inside of there saying all 10 networks subnet mask less than or equal to, and it's passing through. Unfortunately, the matches are only shown if you're doing policy routing, which that's actually the next major topic that we're going to talk about. We won't actually see the matches verified here. We have to either do debugs or just verify the routing table to view them missing. So that's how you can do it. That's implementing a route map filtering in such a way that EIGRP does not see routes with a more specific subnet mask than /24. Now, if you did this lab on your own before you watched me do it for you and walk you through the steps of this lab, could you have approached this by creating a route map that uses an access list to filter? And instead of saying permit any 10 subnet with a subnet mask less than or equal to a /24, you just went in and you said permit that guy, the 10.7, 10.8, 10.9, 10.10, and 10.23, and you individually permit all of those in an access list and then filtered in a route map. Would that be a valid solution? Yeah. It would work. It would totally accomplish the objectives. It would just do it in a non-efficient process. So, of course, if Cisco is pushing you towards this direction in a certification environment, they're gonna do something like, does not see a more specific subnet with existing routes and all future routes, to say if they added loopbacks in the future that the same filtering criteria would still apply. But for now, I will say you can accomplish this objective by using either a prefix list with 1 line or an access list with 5 lines to allow those specific networks. And that, ladies and gentlemen, completes our initial simple redistribution lab. I know some of you might be looking, wow, that was simple? Wait till you see the advanced one. And I know some other ones are probably looking and going, yeah, that was pretty simple. There is a lot that you're able to do with redistribution. So, for now, I hope this has been informative for you. I'd like to thank you for viewing.